Hey everybody, welcome back. In this episode, I want to talk about a little Ruby quirk that is a positive thing about the language that makes Ruby very easy to work with, but it also has some downsides. And what I'm talking about is dynamic typing. So a lot of programming languages out there are strongly typed, like Java or C or TypeScript. You have to declare what type of information that you're going to put into a particular variable. But with a dynamically typed language like Ruby or Python, you could assign anything, any data type to a particular variable. For example, we have this variable x here, and let's assign a value. Let's put an integer in there, x.class. We see an integer in the variable. We could also reassign a value to x, and we could make it a float. X.class, and that's a float. And the same thing goes for strings. And then you could also do more complex data types like hashes and even active record objects. This feature of the Ruby language makes it fun to work with for a lot of programmers because you don't have to concern yourself with typing out what class every variable is going to be and explicitly declaring it. You could get a lot more work done that way a lot faster without that verbosity in your code. But this flexibility that Ruby gives you at times could be a double-edged sword, especially when you're working on something that's enterprise scale and you're doing a very large program, because sometimes the data sets that you're dealing with could get very large and complex with a lot of different methods on them or a lot of different data attached to them. And that introduces the possibility for errors in your code because not everything is strongly typed. And you might try to access data on a particular object that doesn't exist. So let's take a look at how that plays out in this simplistic example that I set up. So we have a vehicle, and we have different types of vehicles from this base class. We could have a car, or we could have a bicycle. And then we could have a sunroof object. The car could have a sunroof. So here we have an open sunroof method that you pass it in a vehicle, namely car, and then it will run open sunroof. So I'm going to run the script file. All right, so it's printing off the status here of the sunroof, which is open, because we went into the file, it initiated this car.new, it passed the new vehicle over to open sunroof, and then it opened the sunroof, changing that variable here, the instance variable, thereby setting the status of the sunroof on the car. Now let's say we pass a different type of object into open sunroof. What's going to happen? So instead of car.new, let's change this to bicycle.new, and we'll run the script again. This time we get an error because it's trying to call sunroof.open, but there's no sunroof on that vehicle. We could even inspect that code. Here I have a binding.pry session. Let's take a look at car. It's type of bicycle, car.sunroof, and sunroof can't be accessed. So being a dynamically typed language, one of the things that Ruby programmers like to do and are sometimes encouraged to do is something called Liskov substitution, which is also known as duck typing. So basically, if we pass in anything into open sunroof that has a sunroof, because it's not checking for the types, it will run that code here, and we could have, like, let's say a truck or something that would also have an open method, and it will be able to run it. But that openness kind of falls apart when you stuff in an incompatible object. So from that standpoint, Ruby is easy to work with because it gives you that flexibility, but it's a double-edged sword because you lack the type checking, and then you could have a bug like this. And this becomes a problem, especially when you're working with really complex data and objects with a lot of different properties to them, which might be similar in a lot of respects, but have some key differences on what's available on the objects. You try to pass them into a method like this, and you have a lot of assumptions going on about what the inputs are going to be. And then your code could have an error in here. In other languages like Java or TypeScript now, a lot of mistakes like this are preempted by the compiler because the compiler will make sure that whatever car is being passed into Open Sunroof will be type checked, meaning that there's no way that it could compile without having the sunroof available on it, because it's going to be a particular type, and it's going to have and one way you could do that is by class type, or you could have an interface which would specify that whatever is being passed in here corresponds to that car interface with sunroof. So what are some ways that Ruby programmers get around this? Well, it's this weakness in Ruby that very strong unit testing, I think, is a lot more important for Ruby programs than it is for other languages, because it's through writing RSpec tests or whichever test suite that you want to use that you could try to test various permutations of this. And it's really hard to test for every particular circumstance, but a lot of errors like this could be caught if you know that certain types of objects are going to be passed into a method like this. Now, another tool at our disposal is the safe navigation operator. And this one will allow you to call pretty much any method on nil without raising an exception. So let's assign nil to a variable, and we'll try to call a method that doesn't exist on it. Okay, obviously, method that doesn't exist does not exist on nil class, but if we use a safe navigation operator, it'll return nil. So in this example, we could use the safe navigation operator to at least guard against nil cases here. And instead of bicycle.new, let's assume that new vehicle didn't initialize property and we got nil. So now I've got safe navigation here, and in our puts over here, let's try to run the script. And nothing happened. It didn't fail without an error. If we didn't have a safe navigation operator, it would cause us a problem. There we go, undefined method. Now, the safe navigation operator is a Ruby feature, and it doesn't really work on objects, other types of objects. It only works on nil type of objects. But if you're inside of Rails, Rails gives you a utility called the try method. So let's have an active record object here. Okay, no method error there on the regular method call. Same result if we use the safe navigation operator. But let's go ahead and try to use the Ruby try method. So in that case, we could use try on an object, and then it'll return nil. So that's an important difference there, where you have the Ruby provided safe navigation operator, and then you have one provided by Rails active support. Now, a third way that we could preempt this type of error from occurring in our program is through compartmentalizing our code so that you have certain checkpoints where you can do sort of your own type checking on the data. And I like to implement this through interactor classes. So here's an example in my program here. We have the screenshots create stonk note class, and this is an interactor class. It just has one method on it call, and it performs a certain business logic function. And the type of argument that it takes is a stonk note, and you pass it in here with the stonk note variable. And something that I like to put in my code to make sure that the object is going to have the type of properties that I want is I kind of break the duck typing principle in a case like this, because we're dealing with a complex object. What I'll do at the beginning of the method is I'll raise an argument error if it's not the type of complex data object that I want. In this case, an active model stonk note. And another advantage to using interactor classes in this way is that you could have this sort of self-contained area where you have a better understanding of what variables are involved and what they should be. And it's a lot easier to unit test a piece of code like this because it's isolated. So this calls screenshot take local screenshot, which defers to another business logic function. And here we have a series of methods that are self-contained. And if we wanted to, we could probably check this ticker symbol to make sure it's a string. In this case, I didn't bother putting in that ghetto type checking. But anytime we reference ticker symbol within this class, we know what it's referring to, which is this. And this call method at the beginning of here is sort of our choke point where we could sort of enforce that sort of type checking on imported variables. Now, this is just my opinion, and one of the ways that I like to design code as a Ruby developer. I'm quite sure there are a lot of other opinions out there. Some developers probably have their own ways of dealing with these problems. If you've got an alternative that you like, feel free to write about it in the comments and let me know. But I just wanted to present one perspective here on one of the things that makes Ruby great, but also kind of becomes a problem when you're dealing with really complex data and how to work around that. So I hope you found this video to be informative. If you liked it, hit the like button, subscribe to my channel for more Ruby content, and I'll see you next time.